Vertical stretches and compressions, changes to the amplitude. So we know that the amplitude of a sinusoidal function is the vertical distance from the midline to the highest or lowest part of the graph. So if I have some function written in this form, and I'm looking at all these kind of wild changes that are possible, well, A is what corresponds to the amplitude, and the absolute value of A represents the value of the amplitude. Now, why are we using absolute value? Well, if A is negative, we know we can't have a negative amplitude since it corresponds to a length or a distance. So the absolute value of A is what's going to give us our amplitude, which is always greater than 0. Okay, so in terms of transformations, when the absolute value of A is greater than 1, well, now I'm doing an outside multiplication, right? This would be the inside changes, right? So I'm talking about an outside change, which are the outside changes are A and D. So when A is greater than 1, what is A doing? A is multiplying by the function. Here we're using sine as an example. Then y equals a sine of x is vertically stretched compared to just the regular y equals sine of x. So why is it stretched? A is greater than 1, it's outside, so I'm going to look at a stretch. Now, when the absolute value of A is in between 0 and 1, I'm multiplying the function by something less than 1. So I would expect the outputs to be smaller and vertically compressed. So this checks out with what we know about transformations. So let's determine the amplitude of each function. Now, again, here the equations are given, but if we didn't have that, we could still determine the amplitude. But let's make sure it checks out with the definition we just learned about. So we know the amplitude is the distance from the top or bottom to the midline. So let's draw in the midline. And for this one, I see it would be this length. Well, based on my scale, right? If this is 4 and I'm starting at 0, this has a length of 4. And I could do the same thing down to the trough here. I'd see that this length here is 4. And again, I'm using positive values only for amplitude. Does this check out with what I just learned? Yep, the absolute value of 4 is 4, so that checks out with my amplitude. What about here? Well, if I am just drawing in my scale here for 1/2 on the y-axis, I can zoom in a little bit here and note that the amplitude, it's always helpful to draw in the midline because the amplitude depends on where the midline is here in terms of going from the midline to the top or the bottom. This length here would be 1/2, and so I note that that matches with the constant that's being multiplied in front of the function. So let's put this together and sketch the graph of f of x equals 2 cosine x minus 1. We want to include at least 2 periods and label 3 points. So what is the midline of this function? Going back to the midline. Well, the midline is determined by the constant that is added or subtracted outside of the function. Well, in this case, I have minus 1, so the midline is y equals negative 1. The amplitude corresponds to this constant that is multiplied outside of the function. So thinking of cosine of x as the parent, 2 times that. So the amplitude is the absolute value of 2, which of course is just 2. The period has not changed because we haven't learned about that yet, 2 pi. Do I have any reflections or horizontal shifts? No. Okay, so then let's put in our, let's see, I noticed the midline is down a little lower. I got burned by that before. Let's put this right here. I'm drawing in my horizontal and vertical axes here. I'm going to make my horizontal scale 4 ticks to 2 pi, and then 4 more ticks to 4 pi. I'm going to do just kind of my usual scale here on the vertical axes where I've got 2 ticks down to negative 1, negative 2, negative 3, 1, 2. Okay, so I'm drawing in. Always good to label axes, x and y. And now I am ready. So I got to draw in my midline first. If you don't know where to start, always start at the midline. Y equals negative 1. And now if I want to draw in my box, I know that the box should be 2 units above the midline and 2 units below the midline. So 2 units above would be up here and 2 units below would be down at negative 3. So above being at y equals 1. And so if I wanted to complete my box, well, unless I'm starting, left or right, have some kind of weird shift going on, my box is just going to start at x equals 0. Okay, and then where's it going to end? Well, it ends at that 2 pi marker. So I'm going to go draw a box like this. Okay, so the midline should cut my box in half, meaning I have the same amount on the top and the bottom. The length, right, the height of the box above should be the amplitude, and height below the midline should be 2 as well. the amplitude, and the box length horizontally should be the length of the period. Yes, I'm ready to go. Okay, then I have to go. Which one am I drawing? This is a cosine function, so I'm drawing the bowl. Bowl starts at the top. Halfway there, it's the bottom, right? This is all nice kind of symmetry that you can use. Now, halfway between the top and the bottom, it's going to hit the midline. So halfway between the top and the bottom, okay, so halfway would be right here. It's going to hit the midline right there. Okay, so I need this point here, and then that's just over here as well. So here is the start of my bowl. Make it curvy. Okay, and now it usually asks us to draw at least 2 periods. So I just make the first one's the hardest, right? And then you're really just copy and pasting. Oh, it's got a little funny. Draw that all the way down there. Okay, so I'm ready for my bowl, top and bottom. The bottom should be halfway in between. And then I'm hitting that midline halfway between the top and bottom on each side. Boom. Boom. And then just drawing arrows in at the ends. It's asking me to identify 3 points. So let's say I have 0, 1. This point here, well, what would that be? If this is 2 pi, I know pi is the second tick, then this tick would be pi over 2. So I notice that this point here would be pi over 2, negative 1. And then this point here would be pi, negative 3. Okay. Now, a negative value of a results in a vertical reflection. So how do we handle that with these? We can just do it with the box, so it's not too bad. So how do we make a sketch? Well, we just perform 2 different steps. So let's look at an example. Sketch the graph of n of x equals negative 2 sine of x. Include at least 2 periods and label 3 points. All right, so I just make my notes over here. Now, what is the midline? Well, there's nothing added to the end, add or subtracted. So the midline is just y equals 0, which is the default. The amplitude is the absolute value of negative 2, which is just 2. The period hasn't changed, it's just 2 pi. But is there a reflection? Yes, since a negative value of a results in a vertical reflection. So, vertical reflection. All right, so I'm going to keep that in mind when I go to draw my function. So here is just my regular horizontal axes. I'm going to draw my vertical axes in. Since my period hasn't changed, I want to just draw in my regular 4 ticks to 2 pi scale. Halfway there would be pi. And the amplitude is 2. Even though I have that negative 2 is kind of funny, I'd still have an amplitude of 2. Okay, so now I have scaled my horizontal and vertical axes, and I am ready to, let's see, draw my box. Okay, so the box is going to be starting at x equals 0. Remember, the box should have the midline going right in the middle. Since the amplitude is 2, it's going to reach 2 above and 2 below, so that should be the height, and the box should be 2 pi long. Now I'm ready to draw. Now what did I get here? I got my sine. Okay, this is sine. So I need a hill and a valley. Well, which one do I draw first? Well, I know that normally sine looks like that, but I have a vertical reflection. So vertical reflection means that I need to do the valley first. Okay. So think about what it would be. So normally looks like this, okay? But because I am doing this reflection, so this is like that, but because of the reflection, I need it to go like that. So valley first, okay? So the valley goes halfway, and then the hill takes over the other space. So in this first half of the box, I'm going to draw my valley. And in the second half, I'll draw my hill. Now again, should hit right there on the box. Okay. And then I want to draw 2 periods, so just draw in my, let's see, any more scale. 4 more ticks to 4 pi. I'll just extend it out that way. Okay. And now I'm ready to just draw in again. So I've got my valley first again because of that reflection. And then I need arrows at the ends of my graph. It's asking me to call out, let's see, 3 specific points. Let's do that. So let's say I use this point, pi over 2, negative 2. This point up here, 3 pi over 2, comma 2. Let's see, halfway, pi, comma 0. And again, I wanted to check. I'm feeling like this was kind of a funny one. I could do that. I could say, what is n of 3 pi over 2? Well, that's negative 2 times sine of 3 pi over 2. Sine of 3 pi over 2. If you don't have that memorized, that's okay. We can use a unit circle. 3 pi over 2 is down here. The y-coordinate on the unit circle there is negative 1. So this is negative 2 times negative 1, which is 2. So do I have the point 3 pi over 2, comma 2 on my graph? I do.